careful, you're driving a 500,000 euros. No, I'm just kidding, it was not that expensive. It's closing in. It's at -20.
That looks pretty good. Wow.
He's in. So now you can see that the finish button is enabled, so if you press that one, you can finish the experiment.
Okay, that's a glitch.
What's the task for? And it aligns again.
What we do here is fundamentally different. We actually control the robots directly by human input. So it is like you as a human stepping inside the robot and taking control of its limbs and hands. And in fact, what we demonstrated today is that the humans can feel the forces that the robot experiences on their own body. So astronaut Andreas Mogensen was directly linked to the robot here on ground through a data connection that was routed over 144,000 kilometer distance. Or driving through a route that is infeasible.
So there are two ways to do this. The first way but actually for roboticists this is enormous. Yeah. And 1 Newton per degree or 10 or 100 Newton per degree of the stiffness, and we change the stiffness level.
We are basically measuring the forces on the robot, and we are modeling the environment here as a stiff contact. We are sending the position of this stiff environment up to the space, and the astronaut is actually interacting with the virtual model of this environment. Wait a bit in the center, and now we are in control again. And you see now that we are 6 centimeters from the surface. Yeah? So
And I need to actually enter the package this over here. And you see the laser indicates very well how the package is in space. With force perception, stiffness perception, and so on. And now in Interact you actually do that through that operation. So we know exactly where.
We use a technology called model-mediated control. This means a model is predicting what would happen in this small distant future. So actually this 800 milliseconds are kind of compensated by this technology.
The onboard ISS, I'm ready for, I think, protocol 2, is it?
What has been before the rovers that were on Mars, actually, they had to be controlled from a distance, so they had to work on their own for like 22 hours, the day cycle of Mars. And you couldn't intervene with them, so if there would be something interesting on the spot, they couldn't adapt. So then you really had to prepare the whole task in advance, and they could only move very slowly and be very safe. If you have the human in control, directly from the orbit from Mars, you can really search for interesting things to look on the surface and really do something like manipulating building a station at Mars, preparing things so you can do much more than just collecting sand and rocks like they're doing nowadays.
It doesn't even have a network that is consistent over the entire station, because it's putting the target by adding a marker here. The camera moves back automatically and he goes in driving mode, and from there he can start driving to the target.